Assalamu alaikum, student. In today class, I'm starting OCR Physics A-level lecture. The topic is electromagnetism. Topic is electromagnetism. Name is showing that it is the connection between electricity and magnetism. Electromagnetism means it is showing that the relation between electricity and magnet both are connected with each other. Okay. In today class, we will study in detail uh, how the relation is formed and how what are the properties belong to this topic. Topic is electromagnetism. Relation between electricity and magnetism. First subtopic of this major topic, electromagnetism. The first topic is magnetic field. Okay, this is the first topic. What is the magnetic field? We can define it by different way, magnetic field. But when we study the topic electromagnetism, we define it by the relation between electricity and magnetism. According to electromagnetism, a magnetic field is a region or space in which moving charged particle subjected to a magnetic force. Okay, I am defining this one by electromagnetism. Okay, for example, this is a magnet in which there is a one north pole and south pole. When two magnets are placed near to each other, two poles, now how the magnetic field moving? It is moving from the north to south. I am defining the electrical field with respect to electromagnetism. Okay, student? Now try to understand it. How I am defining the magnetic field? When a charged particle, just like electron or proton, moving inside a magnetic field. Now, what happens when charged particle moving inside a magnetic field? Uh, a force is applied on it. Third quantity, force. Okay. Charge is moving between the magnetic field. Now, third quantity is force is here. This force is applied on a charged particle. I will further define it, how the force is applied and what is the direction of the force. But here I am basically explaining here about the uh, magnetic field. Normally, we define the magnetic field, magnet, area or region around a magnet in which magnet influence a force on another magnet or magnetic material. Okay. Normally, we define as a magnetic field. There is a magnet, and when we bring a magnet near to it or a magnetic material, magnetic influence on it. And if there is a magnet, then same pole repelling, opposite pole attracting. This is the definition according to the magnetism. Okay. But here I am defining the magnetic field according to electromagnetism. Okay. It's mean I am describing it with the help of electric and magnetic field. A particle's electron or proton, when enter into the magnetic field, it's mean moving in a magnetic field. Now what happens? This particle feeling a force. Force is produced on the particle. Now, how we define the magnetic field according to electromagnetism? A magnetic field is a region or space in which moving charged particles are subjected to magnetic force. Now, this is the magnetic field. When a particle entering in a between the magnetic field, now the experience of force, a space or area in which this field is applied on the charged particle and a force influence on it, this area or space we call the magnetic field. Okay. If you demand notes, then comment me on comment side. I will provide you the notes. Magnetic field is a region of space in which moving charged particles are subjected to a magnetic force. Magnetic field is a region or space in which moving charged particle subjected a force. Okay. When magnet applying the force, magnetic applying the field, magnet applies the field, and charged particle when enter in it and moving experience of force. Space in which this charged particle experience of force, this space or region is known as a magnetic field. Okay, student, now clear? Magnetic field. What is the magnetic field? What happens when uh, current is moving in a coil or wire, and there is a magnetic field? What happens? Now, this wire experience a force. Okay, for example, current moving in this wire. This is the wire, and it is placed between the magnetic field. Magnetic field always moving from north to south. Now, what's happened? Uh, this field and the movement of the magnet, uh, movement of the charge, the third quantity producing here the force. Why the force is produced? Because when current or charge moving in a coil, now there is a magnetic field produced around the coil. When these two magnetic fields, magnetic field of magnet and the field which is produced in a coil due to the moment of charge, when these two are interacted with each other, now there is a force produced. We know that when just like in magnet, what happens when two same poles are placed near to each other? Now there is an interaction form, magnetic field interaction form between the poles. Now magnetic field interaction form, now there is a force form. Similarly, when charged particle moving in a coil producing magnetic field, and there is a magnetic field also outsidely. When charged particle moving and the magnetic field produce these two magnet field force and the charged particle which is moving in a coil also having a magnetic field. These two field when interacted with each other, now there is a magnetic field, magnetic force, field force produced. So when charged particle moving in a magnetic field or coil or wire placed in a magnetic field, this coil or charge feeling a magnetic force. Um, one magnet is known as a permanent magnet, mean it is natural magnet, permanent magnet. In this magnet, magnetic field always producing outsidely north to south, and the domain is formed insidely from south to north. And this is a natural property of a piece of material. Now, this material is known as a permanent magnet. When this is naturally placed uh, property, this is the permanent. Some materials are that material which are the magnetic material. These, when comes in contact with magnet, these are also becomes a magnet. Just like we attach a nail with nail is a iron piece, okay? When we attach a nail with a magnet, what happens? This nail convert into magnet. Now, this is not permanent magnet. This is induced magnet. Magnetism is formed in the nail, and when we bring this nail near to the permanent magnet induce a magnetism into the nail, and nail becomes a magnet. Now, these are the magnetic material which change into magnet when we bring near the magnet. Okay. Now these are the magnetic materials. Now I told you four things here. Number one, field, magnetic field. Number one, I told you the magnetic field. Magnetic field we can define according to two way, with the help of magnet or with the help of electrical field. Electromagnetism. We can define the magnetic field by magnet or electromagnetism. In both conditions, we can define what is the magnetic field. We can define the electric field with respect to magnet or electromagnetism. I told you in my lecture. Now, secondly, I told you the permanent magnet or temporary magnet. Permanent magnet, which is formed, permanent magnet, it is formed due to its natural properties. And there is a domain present inside the magnet which make the piece of substance in magnet. And temporary magnets are that magnet which produce due to the effect of which change into magnet due to effect of magnetism. When magnet bring near to a magnetic material, now this magnetic material change into magnet. There is an induction form. This induction induces the magnetic material into magnet. These are the magnetic material. These are naturally not magnet. There is no domain inside the substance, but when we bring these substance near the magnet, these will change into a magnet. Now I'm telling you uh, when a current passing through a coil or wire, what's happened in the surrounding of coil there is a magnetic field produced. We can understand this magnetic field with the help of right hand rule. Right hand rule can describe the direction of the current and the magnetic field which is produced around a coil or wire. For example, we grip the coil just as thumb is in upward direction and fingers gripping the coil, thumb is upward direction. We grip the coil in right hand, thumb in upward direction, and fingers gripping the coil or wire. Now, what happens? These finger grip showing the magnetic field, magnetic field lines. When grip the coil just as when current moving upwardly, now finger bend around the coil, around the wire like anti-clockwise, okay? Anti-clockwise direction. And secondly, what happens when current moving in a coil in downward direction? When we grip this one with right hand and thumb is in the direction, downward direction. Now finger here representing the grip like this one, clockwise direction. Now, this grip is in the clockwise direction. When we grip the wire in hand and moving, thumb showing the downward direction. Now fingers showing the magnetic field direction. Thumb showing the current direction and finger showing the uh, band direction. Now it is known as a um, basically the magnetic field. Now the magnetic field in clockwise direction. Magnetic field is in the clockwise direction. Now I'm here describing it by some diagrams. On Google, I'm describing this by some diagrams. What is the right hand rule, grip rule? Just like this one. When you grip the coil like that, when you grip the coil, your thumb is in upward direction and your fingers uh, gripping the coil like that. Now your finger direction showing that uh, magnetic field direction. Okay. Now when you're gripping like that, thumb showing the upward direction and finger showing the magnetic field. This magnetic field is in the anti-clockwise direction. Okay. When you grip the coil as thumb is in the downward direction. Thumb is in the downward direction. Then your finger showing the grip like clockwise direction. Okay. Get that? Then thumb is in the downward direction. Now this one. You grip a coil like that. Your thumb is in downward direction, like that. You check here. Now your finger gripping like this one. Now here your finger showing the magnetic field is in the is in the clockwise direction. Okay. Now this is the right hand grip. With the help of this rule, you can explain the direction of magnetic field and direction of current. It means when current is moving in a coil, now there is a magnetic field produced. It may be anti-clockwise or it may be clockwise in the clockwise direction. Now, it's mean there is a relation between the current and magnetism. When current is moving inside a coil, it is producing a magnetic field. Now, I am telling you, how can we make a electromagnet? How can we make electromagnet? If we wind up a coil on a magnetic material, not magnetic material, like a rod, like a nail, if we wind up coil uh, and we connect the coil with DC supply, with DC supply, battery or cell, when current is moving inside throughout the coil, when current is moving, when we apply the DC supply plus minus, current is moving from positive to negative. Now in this coil, current moving like that, okay? And it is moving from positive terminal to negative terminal. When current moving with the help of DC supply in a magnetic material, now what happens? This magnetic material change into magnet. due to effect of electricity. This means when electricity passes through the coil and this coil is wind up on a conductor, and when we apply the DC supply, direct current on this conductor with the help of coil, now what's happened? This magnetic material change into a magnet. When we remove the electricity, uh, the magnetic material change again into normal substance. Now, electromagnet produce when we pass the electricity through a coil. Now, it will be electromagnetic. Now, some substances are the magnetically hard, and some substances are the magnetically soft. When we apply electricity on a magnetic material, it will be it will be changed into magnet, and their property retain for a long time. It is a hard magnetic substance. And soft magnetic substance, when we change the magnetic material into a magnet, and the properties will finish immediately. When you remove the current, then it will change again into normal magnetic material. Now, these are the soft magnetic material. Now, clear student, what are the hard magnetic material? When we change due to electricity a magnetic material into magnet, it will retain its property for a long time. This is the hard magnetic material. When we change a conductor or magnetic material with the help of electricity into magnet, it will not retain its property for a long time. These are the soft magnetic material. Okay, now I will continue my lecture on electromagnetism. Continue, inshallah, in tomorrow class, maybe in 2 or 3 class, this topic will finish. I will tell you all the topics which are present in the chapter in detail. Inshallah, subscribe my channel and get more videos. And if there is any problem comes in understanding, then tell me on comment side. Then I will make further video for you and further explanation for you in other videos.